Okay, so question 5, a massless string connecting blocks of mass 5 kilograms and 3 kilograms. So 5 kilograms, 3 kilograms, and the first step is to draw the free body diagram of the block and denote a positive direction for each. So for the 3 kilogram block, because I suspect that it's going to move upwards, I'll make up positive. So this is tension on the block by the string for the 3 kilogram. Here is the weight on the block by the earth for the 3 kilogram. Okay, for this 5 kilogram block, I'll make down positive because I think it's going to move down. Tension on block by the string for the 5 kilogram block, and then weight force on block by the earth for the 5 kilogram. And actually, this is not consistent. I should make that vector bigger because I know that it's got more weight than the 3 kilogram block. So what is the acceleration of the system after it's released? Okay, so we need a system of equations because clearly there's two unknowns. I don't know tension, and I also don't know the acceleration. Okay, I don't know tension, and I don't know the acceleration. So for the 3 kilogram block, net force in the y direction equals MAY, and tension minus weight is going to equal mass times, so M3 is going to be mass of the 3 kilogram block times acceleration, and I have TBS3, and I'm just going to add the weight to the other side, equals M3 AY plus mg is weight plus mg. Okay, now I can't do anything because I don't know tension, I don't know acceleration, but I can do something to the 5 kilogram block as far as net force equals ma in order to get a system of equations. So net force in the y equals ma in the y. So for the 5 kilogram block, because down is positive, I have weight on the block by the earth. The 5 kilogram block minus the tension force equals the mass of the 5 kilogram block times the acceleration. Okay, so I can move tension to the other side and then subtract the M5AY, so minus M5AY plus tension. And that's going to give me mg, so that's the weight. Okay, that's the weight right here. Weight minus M5AY equals tension. Now the tension, remember, is going to be the same because this is a massless string. So I'm going to take this tension and I'm going to plug it in right there. Okay, so once I plug it in there, I have M5G minus M5AY equals M3AY plus M3G. So I'm going to put the accelerations on the same side and move the mg's to the same side. So then I have M5G minus M3G equals M3AY plus M5AY. Okay, so when I factor, on the left side, I factor out a g, and I get g times M5 minus M3 equals, and here I'll factor out AY, M3 plus M5, divide by M3 plus M5, and I get AY equals G M5 minus M3 over M3 plus M5. When I plug in values, that's 10 meters per second squared times 5 kilograms minus 3 kilograms, so 2 kilograms over 3 kilograms plus 5 kilograms, that's 8 kilograms, so that's 20 divided by 8. So acceleration is 2.5 meters per second squared. So now, in order to answer the question about tension, I can go back and plug this value in for A. And so I could look at any of my equations that have tension. I can look at this one, or I could look at this one. It doesn't matter. So I'll just say tension equals M3AY. So 3 kilograms, and I'm using this one here, 3 kilograms times 2.5 meters per second squared plus 3 kilograms times 10 meters per second squared, and that's going to give me a tension of, let's see, 246, 7.5 plus 30. And you will get the same answer no matter which tension equation you solve for. Then how does the tension compare to the weights, and explain why this must be so according to Newton's second law? Well, the weight of the 3 kilogram block was less than tension, was less than the weight of the 5 kilogram block, which means that the 3 kilogram block, if tension is greater, will have an acceleration upwards. So the 3 kilogram block will move like this. An acceleration will point up. Does that happen? Yes, it does. And then for the 5 kilogram block, it'll move like that. An acceleration points down, and yes, it does. And that's because the net force equals ma for the 3 kilogram block results in a positive sum of the forces. And since we said positive was up, we get this. And the net force equals ma for the 5 kilogram block. We said positive was down, and our net forces are in fact down. Yay! Good job, guys.